Teesta Isser is a reliability engineer in Tom Price, Australia. Teesta has a master's degree in physics and is well-travelled. And she is also partial to defying gravity occasionally. Teesta is seeking $74,000 from the panel to use thermography on bins and chutes to monitor liner wear and determine what liners need changeouts in an upcoming shut.
I'm nervous. I always wanted to have that Archimedes Eureka moment. And I was like, I wonder what would happen if we used thermography for bins. Well, I'm happy that I got this far, so win or lose, I'm going to feel like a champ.
Looking forward to your pitch. If you could get underway, it'd be very much appreciated.
So thermography is basically a method which detects infrared energy that is emitted from an object and converts it into a temperature value and then displays the image of that temperature distribution. Currently, all the inspection for liner wear monitoring is done offline in terms of either thickness testing or 3D scan. Also, the frequency of these changeouts is very high. In the last year, we've had about 840 events of unscheduled loss downtime due to damaged chute and liners. You need permits and isolations, you need this equipment to be offline, and there are critical risks of falling, of confined space, and uncontrolled release of energy. Using this method of thermography, we can eliminate all these three critical risks when it comes to doing this job. So using this, you can accurately map out what temperature rates correspond to what thicknesses and predict the liner changeouts before the shuts without having to go offline. In May 2019, we'll do our final thickness testing and thermography and confirm the findings, which will theoretically be the proof of concept and pretty much be on go, no go. For bins and chutes, the primary failure mode is liner wear. And just for that, it was about $18.9 million across all the sites. And also there's an opportunity across Rio Tinto Iron Ore for savings of $300 million and subsequently maybe even other product groups.
You said you'd done 2 previous trials on site. I just wanted to try to get some insights of what you may have learnt from those trials, some do's and don'ts. Could you elaborate on that?
The first 2 trials were us basically sort of finding our way, and then the second trial we did at 6 o'clock because that's the only option we got. And then we realized very quickly that no, you can't do it at 6 o'clock because your ambient changes too fast. But I think I'm convinced enough that in a span of 6 months it should yield good results.
That is a stunning return, 75,000 for 300 million. Can you describe where you've got the 300 million from?
I've used the loss sums that's there on Ampla. Now, obviously, different sites have different rates of calculation. There's small calculations that you need to sort of look at. It might be more savings, but I've taken like a conservative amount of loss sums.
From your perspective, does thermography and this new way of working increase any new risks that we should be aware of?
If there was a critical risk in that, it would be the same as, say, someone going there and doing hosing, standing on that walkway, or something like that. So I don't think it would be a new risk, but yes, the 3 critical risks will be eliminated because you won't be needing to go into it.
Thank you very much for a very clear and very important pitch.
I think it went fairly well. I think the whole experience was, with the coaching and everything, was quite eye-opening. I feel that I'm somehow better for having gone through the process. And yeah, looking forward to the results.
In the next episode, we'll see Yarwin's Maxim, Thomas and Johan pitching for $200,000 to automate flash tank cleaning, which they believe could improve safety and potentially save millions of dollars.